Kia ora. So, ko Denise Wilson Taku Ingawa. I'm going to chair the session this afternoon. So we've got 3 people who will do their presentations. First up, I'd like to welcome Professor XioQi Chen from South China University of Technology, and he's going to talk to us about intelligent robots for better commonwealth of humankind.
Just press and start. All right, fellows, colleagues, ladies and gentlemen, good afternoon. I thank Royal Society of New Zealand for electing me to the honorary fellow of the society, an opportunity for me to share some thoughts on intelligent robots for better commonwealth of humankind. So I'm getting more, gray hair. So it's time to reflect more on the journey I have gone through. So during my joyful childhood, 3 things are memorable: fatigue, hunger, and flood. Despite the hardship, I had a dream to design automated machines that can plow, sow, and harvest. So I didn't return to the village as a content expected by my villagers. I went to the South China University of Technology. After that, I continued my postgraduate studies in UK, thanks to the UK-China Technical Cooperation Scheme. So started my journey of research, teaching, and learning. So that's my postgraduate studies. So my master's studies really just focus on mathematical modeling of submerged arc welding. So I learned to program Zilog Z80 8-bit microprocessor to control 3-axis welding robot. Right? Then the lab technician came up to me. Did you do it? No? Easy. It did it. I pointed to the machines. So the technician just stared at the machine and me in awe. So that facial expression never faded in my memory. So I continued to PhD study at the Liverpool University, working on vision guides, narrow gap, robotic welding. So I literally buy microprocessor chips. I built a motion controller with Intel 8085 to control 4-axis robotic welding systems. Then built a vision processor using Intel 888. The robotics development benefited from the phenomenal growth of computing power. So the chip I used, Intel 888, had 29,000 transistors. Nowadays, a high-performance CPU chip has 30 billion. 30 billion, right? That is 1 million times of the chip I used. So in 1990s, my team developed a smart robotic system for remanufacturing of air engine components. As I flew into Wellington yesterday, many air engine parts are repaired after certain flight times. So I was working on the robotic machines which can repair, remanufacture those parts to keep our flight safe. So that is not easy because we're dealing with the parts of individual characteristics, individual profiles. But anyway, we have managed to crack 2 major problems. One is to detect and reconstruct deformed profiles. So the machines can be adaptive to parts of individual characteristics. Another thing is use force, like a human being doing those grinding or doing those handiwork. Use force to control the material removal. So to make sure the finished profile is within micrometers tolerance. So this is the fun part I did at the University of Canterbury, right? In 2000s, I was presented with this challenge, right, to automate inspection of large stainless steel tanks. Why we need to do that? It has to be done periodically to identify any defects where the bacteria may grow and affect the food safety. Right? So we were given this challenge to automate a task of 6 persons, 6 hours, to 1 person, half hour of machine time. So a lot of science going on. So my first idea was to develop non-contact adhesion mechanisms, which is great. So the machines can work literally on any wall surface of any conditions, rough, gaps, right, bumps, or any materials, wood, concrete, even this wooden doors, with the gaps, the machine has no problem to cross. And remarkably, it can carry weight twice of its self-weight. I hope I have that capacity, but anyway. So that machine is wonderful. But it has one big problem. It must be tethered for the flow of compressed air. That tethered pipe is additional weight, which the machine doesn't like. And also, when the airflow goes high capacity, the pipe just gets stiffened, which is not good for the mobility of the robot. So that challenge threw us back to drawing board. We have to start with new things, and new ways for machine to climb on the wall. So we started on the untethered wall climbing robot. And we made a breakthrough in 2 things. The first thing is motorized priming to achieve the adhesion efficiency. That means get more payload for small machines. The second thing we did is to mimic human beings for climbing poles and trees. We detect the adhesion force, make sure it just has enough force to cling to the wall to conserve energy. That way, the machines run hours instead of minutes. Right? This breakthrough opens up a wide range of applications. So, intelligent robotics benefits the advancement of computing, sensing, so on and so forth. In recent decades, there has been an explosion of developments of intelligent robots. You see robots, entertainment, robot girlfriends, if you don't like our human companion. AlphaGo defeating the Go World Championship in the humanoid robot, biologically inspired robots, etc. I supervise PhD students working on numerical artificial muscle-driven lower limbs, right, for users. But the world faces a grim reality: natural disasters, pandemics, and wars. So I experienced an earthquake in Christchurch, first time in my life. When I went to Melbourne 4 years ago, there was a big bushfire. Right? So we have to ask ourselves what AI and those intelligent machines can do to help us solve fundamental issues that the world is facing. So according to the report by International Federation of Robots, in 2021, China had 268 robot installations, surpassing the rest of the world combined at 249,000. The global average manufacturing robot density, defined as the number of robots per 10,000 manufacturing employees, is 141. The robot density in China is 322. The robot density in the United States is 274. I think soon we will see the rise of manufacturing powerhouses: India, China, of course, and possibly Vietnam. This change will affect the dynamics of geopolitics. Do we have a collective wisdom to manage the dynamics? There's another challenge demographic. The population is projected to increase from 8 billion now to 90 billion in the middle of the century. Right? Split between 10% in the developed world, 90% in the developing world. So what are we going to do with this population increase? Right? How can AI and robotics technologies benefit the whole world? Will the robot population reach 90%? Sounds ridiculous, but 40 years ago, has anyone predicted everyone will have one mobile phone? So robots will become smarter and more functional. They can be used to serve and enhance the well-being of humankind. But imagine we give robots artificial conscious, artificial souls, artificial emotions, and how the robot will collaborate with human beings. How would the robot interact with the human beings? What does it mean to be a human being? What is the most precious thing in our life? If we as human beings do not know the core meaning of our existence, how do we expect ChatGPT give the answer to the fundamental questions of our own? Fellows, colleagues, the tide of AI-powered robots turn higher and higher. In riding the wave, we need to guard our hearts. AI and intelligent robotics cannot be allowed to enroll, to undermine the very meaning of a human being. We ought to responsibly advance intelligent robotics for a better commonwealth of humankind. Thank you.
We've got time for a couple of questions. Does anybody like to ask a question?
Yes, Mark?
So there's been calls from various computer people that we should take a pause on AI and its development. It's moving too quickly. Is that something you would agree with?
I cannot entirely agree whether we should pause the development of AI or robotics. I think we just need to responsibly advance the technology. So now you perhaps hear, robotics ethics. I think the international community has to pay attention to AI, robotics ethics. I know among us, there are people in philosophy, social science. These are the issues that have to be addressed across the entire communities.
Anybody else like to ask a question?
Thank you, Jeff.
So, if you expect AI in the future to be socially and ethically responsible, doesn't that make it a person?
So that's precisely the point I want to get across. If the AI has lots of artificial things, emulating human beings, isn't that considered as a robotic being or equivalent to human beings? Actually, I struggle with it. What is AI? What are the fundamental things of AI? So I've taught this course, mechatronics design, to my students. What is the basic unit, fundamental things of these intelligent machines? It's nothing but a bunch of switches. How can a bunch of switches, millions, billions, of course, I explained to you, generate certain things which looks equivalent to human beings, overpower, replace the inventors? This is something I have to struggle to come to terms with. All these things you notice that, data representation, the algorithms, they run on switches for half centuries. So that illustrates, if you create a simple device which can provide such a capacity capabilities, how great we are as human beings. Thank you.